Alrighty guys, so I'm going to go over the final exam review with you guys. I'm going to only do problems that are essential, I guess, in a way. I think the ones that are harder for you guys, so I'll skip around. Feel free to pause just to make sure you know what I did. I might go a little fast, but again, make sure that if you think I'm going fast, pause so that you know and try to figure out what I'm doing, okay? So let's go ahead and get started. So for the review for Math 120, the first and the second problem, they're very similar. I'm just going to do one of these. All right, so on the first one, it says, give the slope of this equation and write a sentence that explains the meaning of the situation. So on number one, the slope is the number in front of the variable, so 12. That's the slope. What does it mean? So it says P is the profit. The gross profit is P of ExxonMobil. T years since 2000 can be represented by the equation. So that means that the slope is years, right? And so as every year goes by, the ExxonMobil profit increases by 12 billion, okay? Exxon profit increases by 12 billion each year. Okay, so Exxon's profit increases by $12 billion each year. That's what the slope represents in this problem. All right, let me erase this just so that I can have enough space. P-intercept, the y-intercept. So the y-intercept is that one. That's your B or your y or your P-intercept. And so in this situation, 0, 13 is your y-intercept, your p-intercept. What does it mean? It means that at the starting point, Exxon had 13 billion. Well, what's the starting point? In the year 2000, Exxon's profit was $13 billion. All right, something like that in complete sentences as best as you can. But that's the slope, the y-intercept, and then the meaning of it. You need to write a small sentence just to make sure that you guys know what the situation is. Okay, 3 and 4 are very similar. The thing with 4 is the initial value a is negative, and so this is going to be a concave down parabola. This is going to be a concave up parabola because of the a. That value is negative, concave down. All right, so I'll just do one of these. Let me do number 3. It says, does the graph open up or down? Like we said, it opens up because the a is positive. The 2 is positive. What is the vertex? The vertex is 3, h and the k, comma, negative 4. Notice the h, the 3, is always opposite sign. The axis of symmetry is always the x value of your vertex. The vertical intercept, that means the y-intercept. When we're finding x and y-intercept, it depends what we're doing. Y-intercept, we replace x as 0. So I'm going to replace x as 0. F of 0 equals 2 times 0 minus 3 squared minus 4. So this is going to be 2 times negative 3 squared gives you 9. 2 times 9 is 18 minus 4 gives you 14. All right, I found the y-intercept. The y-intercept is 0, 14. And remember that your answers, that way you guys can check, are always at the end. So we were doing number 3D. Notice that's the answer. All right. What else do we have to do? The point symmetric to the vertical intercept. All right. So here you don't have, it's not part of the problem, but if you graph it, it's a little easier. All right. So the vertex, well, we're just going to do like a sketch, not a real graph. So 3, -4, we can say it's there. 0, 14 is here. A parabola, that's 0, 14. So we're trying to find this point. If the vertex is 3, -4, you travel 3 to the center, because that's the x, another 3. That will put us at 6, 14. So this is 0, 14. The other one is 6, 14. So 3e, we get 6, 14. And then lastly, the domain for parabolas is always all real numbers. You can say the sentence, all real numbers. This is a symbol for all real numbers. That's the domain. The range is going up and down. So the lowest point is at -4. The highest point, the parabola goes up forever. So your range is from -4 going up to it forever to infinity. All right, that's the domain and that's the range. Number 5. Number 5. What does that graph look like? It looks like a exponential. If it's exponential, it says here you need to find the base multiplier. So the b, if you look at the data, it's growing by a multiplier of 3. 6 times 3 is 18, times 3, 54, so on and so forth. So your base multiplier is 3. What does this one look like? It looks like a line. It's a linear function. If it's a linear function, you need to find the slope. So the constant, if you look at the data, the constant decrease is by -3. So the slope is decreasing by -3. Lastly, what does this one look like? It looks like a parabola. Those are called quadratic. And it says in the instructions, if it's a quadratic function, you must find the vertex. And so the vertex is, in this case, the highest point. And I can see this is the highest point right there. 2, 7. Perfect. All right. Number 6, 7, and 8, they're the same. Different type of graphs, but they're the same. So I'll just do one of these. Let me do number 7. Estimate f of 5. This notation, 7a, f of 5, represents when x is 5, what's the y? So I go to the x-axis, 5. I go follow the graph. When x is 5, y is 2. Estimate the x values when x is 1. No, when f of x is 1. That means that the y value in this case is 1. It's right here. That's the y value right there. And this is the other y value when these are the two x values when y is 1. We just need to figure what that is. That one looks like it's close to 5. I can say 4.7, 4.8. That one is more than 9. 9 point, let's say 2. So this one gives you 4.8 and 9.2. And as long as you're within the range, it's reasonable, it would be fine. If the answers are a little different, it's okay. Instructors or I will grade it accordingly. So let's see number 7, 4.8, and 9.2. If you would have said 4.7, again, I accept it. It's within range. All right, so that was number 7. Oh, we're not done actually. the horizontal intercepts. That means the x-intercepts. The x-intercepts, that one right there where it crosses the x-axis, that seems to be 4.5 comma 0. They want it as points. The other one right here seems to be 9.5 comma 0. Those are the x-intercepts. Domain and range. So domain, since this is a parabola, it's all real numbers. The range going up and down. The highest point is 6. The highest y value is 6. The lowest y value goes down forever, negative infinity. The highest always goes on the right. In case it's not clear, the first one should be a parenthesis. The second one should be brackets because it includes the point at 6. All right, let's keep it going, guys. Number 9, and number 10 are similar. Whichever one you guys want to try to tackle. Let's do number 10, I guess. So when I need to fill in this table, there should be an f there, okay? F of x equals 4 to the power of x. And so let's fill in the table. Let's start with f of 0. I replace x with 0. 4 to the power of 0 is 1. Anything to the power of 0 is 1. Replace x with 1. 4 to the power of 1 is 4. 16. 64. This right here is 1/4. Okay, so we complete the table. And then we're going to find the inverse. Well, I'm skipping around, right? Because this was number 1. Find the inverse. So I need to find the inverse of an exponential. It's a logarithm. A logarithm base is 4 of x. That's the inverse. Inverse of exponentials are logarithms. Log base 4 of x. The same base as the exponential. And then we fill the table, which we started. And then the inverse, we know the values always flip. So 1/4 would go here, 1, 4, 16, and 64. And then the y values on the inverse are your x values of the original function. Again, if I'm going too fast, don't forget, you can always pause, okay? We're going to graph these. The first one is an exponential. That's 0, 1, 1, 4. You'll have the grid on the test, so you shouldn't have any trouble here, okay? 2, 16, negative 1, comma 1/4. I know that an exponential function looks like this. All right, don't forget to label. And I know I'm not doing the best of jobs. I don't have too much space here, guys, but you should try to do it a little bit better on graphing paper or something like that, okay? 1, comma 0. My goodness. 4, comma 1. 16, comma 2, negative 1/4, comma negative 1. So this is the inverse. And this is the original function, f of x. All right, so they reflect across the line y is equal to x. Alrighty, guys, let's keep it going. Number 11, I can do one of these, but what we have to do is replace, let me do C. So what I have to do is replace the x with a half. What does an exponent in fractions means? It means roots, and so the answer is 4. Let's try maybe another one. F of negative 1, What does exponents that are negative mean? That means that we get a fraction. We put it in the denominator. Okay. Let's try number 12. The harder one that I see on 12 is B, so let's give it a try. The first thing that I'm going to do is reduce what's inside. 18 over 9, that gives me 2 over 1. We don't need that one. I'm just putting it as a placeholder. What do you do with exponents? When you divide variables, you subtract them, right? When you divide, you subtract exponents. When you multiply, you add exponents. So m is going to be 2 minus negative 4. That gives you 6. And negative 2 minus, because we're dividing, negative 5 is going to give you n3. Okay, negative 2 minus negative 5. Negative 2 plus 5 is 3. Okay, now the next thing that we're going to do, since the exponent on the outside is negative, I'm going to flip the fraction to make it a positive. And now this 3 becomes a positive. Positive 3 instead of negative 3. We just flip it around. That's all we're doing here. And the last step is cubing everything. 1 cubed is 1. 2 cubed is 8. M to the 6 cubed, we multiply exponents. N to the power of 3 raised to the power of 3 again, you multiply exponents, n to the 9. So this should be the answer, okay? You can always check back to number 12b. Notice how that's the answer, 12b. All right, let's try maybe one of these. G, oops, the wrong one. G of 36, that means that we gotta replace x with 36. Logs, remember they're exponential functions. They're exponent, you can always change them to exponents. So log base 6 of 36, what that really means is 6 to the power of what is 36? Well, 6 squared, right, is 36. That's why the answer to log base 6 of 36 is 2. Let's try 14. They're all very similar. We should try one of these. 14a. Again, a log function is an exponential function. You just need to be able to convert it correct. I usually tell these students to follow this rules here, these symbols. It's easier to do it this way. So 4 would be your base. The 1/2 is your exponent equals 2x. It always goes like this as long as you remember it. And so an exponent that is a fraction, we said it's the square root of 4. And so that will give you a 2. How about C? What's a base on logs? If there isn't one like this one, there's a base 10. 10 to the power of 6 equals 2x. 10 to the power of 6, 6 zeros, 100,000. Oops, that's not 6 zeros. That's 6 zeros. 1 million. Let's check 14. There we go, 14. All right, let's try inverse. We did an inverse like B up here on number 10. So 10, just for 15b, follow the example on 10. We did the inverse up there. So like we said, exponentials are logs the inverse. The inverse of a log is an exponential. So if I want to find the inverse, I put the base is 10 to the power of x. I change it to an exponential. You know what, I'll do 15b since I'm here. The inverse of an exponential, it's a log. log base 6 of x. Now to do c, I'm going to do a little bit of work because it's a linear equation, a linear function. So I'm going to replace the h of x with y, interchange the x and the y. Once I solve for y, that will be the inverse, okay? So I'm going to subtract 1. And then I'm going to divide everything by 3, negative 3 that is. And I get that as the inverse. Again, make sure you use the right notation. H inverse of x equals 1/3 of x plus 1/3. All right, we found the inverse of all these three problems. For 16, let's do only one of these. Let's do C. I'm going to compress it. So I'm going to compress 16C. The first thing that I'm going to do, this goes as the exponent, that goes as the exponent, this goes as the exponent. X ln of x squared, that doesn't change. What changes is here, you need to square both things. So this will give us 9. 3 squared is 9. Z squared. And then again, over here, you're going to brace both to the 4th power. Okay, so the last step, we're going to combine everything into a single log. First one, 5x cubed. When there's a plus right there, you're going to multiply. There's a plus right there, you're going to multiply. There's a minus right there, you're going to divide. And then lastly, don't forget to simplify everything, okay? I'm just going to do this in one step because I'm running out of space here. So it's going to be 5x cubed times x squared, 5x to the 5th. Oops, and then the 9 times the 5, that gives me a 45 in here. 45x to the 5th. Z squared, it cancels with z4 in the bottom. So instead of z4, we have 2 z's in the bottom, and the y to the 4th in the bottom is left because it doesn't cancel with anything. So this is my final answer, okay? That's how to take a big logarithm like 16c and compress it into a single logarithm. All right, 17. How do we find domain of rational functions? All you do is you take the denominator, doesn't matter which one. Let's do 17b. You set it equal to 0. Find out what makes it 0. You're going to factor this. Differences of two squares. X equals 4. X equals negative 4. So what makes the denominator 0 is if x is 4 or negative 4. Your domain, we're doing B. So your domain is all real numbers except 4 and negative 4. Okay. That's to find domain. You do something similar on 17a. Now on 18, notice the problems look the same, but they're asking you to do different things. On 18, they're asking you to simplify. So we're going to simplify the right side by factoring. On the top, what can I factor? I can factor out of 4. The bottom, we factored it on the top. cancel like terms. You're left with this simplified. Okay, that's all they're asking you guys to do. Alrighty, on number 19. Number 19, what we need to do when we add and subtract A or B is need to have the same denominator on both of these. So let me try against 19b. The x plus 2's are the same, but this one needs an x minus 3. That way they both have the same denominator. So 2x and then x plus 2, x minus 3. And then on the top I'm going to multiply x squared minus 3x over x plus 2, x minus 3. Same denominators. I add numerators. X squared minus x over x plus 2, x minus 3. All right, that's it. That's it for 19b. For 19c or d, doesn't matter which one. I'm gonna do d. When you guys do c, since it's division, make sure you guys flip the second fraction, okay? But if I'm gonna do one of these, I'm gonna do d. It's already multiplication, so all you guys gotta do is factor and cancel. That's the easy part of canceling. The hard part is the factoring. So I'm gonna do it a little quick. You factor out a 2. The bottom, I'm going to factor out factors of 15 that the sum is 8. N plus 3, n plus 5. 5 times 3 is 15. 5 plus 3 is 8. Factor out a 3. The bottom, in order to factor, you need to find factors of 28 that the sum is 11. N plus 7, n plus 4, and then all we do is cancel, all right? These cancel, they're the same on the top and the bottom. These cancel, and we end up with 2 times 3 on the top, which is 6, and the bottom, n plus 7, n plus 4. All right, that's how to do C and D. Very similar steps. You guys can do the rest. All right, I'm gonna do one of these. I'm gonna do 20C. I think it's a harder one. In order for me to do 20C, what I have to do is find a perfect cube root. So 40 is not a perfect cube root, but I know that 8 is, and 8 times 5 is 40. So I'm gonna split it into 8 times 5, which is 40, because 8 is a perfect cube root. 8 to the 6, since it's divisible by 3, on variables they have to be divisible by 3, works. B to the 10th, the 10 is not divisible by 3, but I'm going to split it into 9 because 9 is divisible by 3 times b to the 1. Notice how I split everything so that all of these have perfect cube roots. Now let's do the cube roots. Cube root of 8 is 2. 2 times 2 times 2 is 8. Cube root of 5 doesn't have one, stays inside. On variables, like I said, the exponent has to be divisible by the index number. So 6 is divisible by 3. And so a squared. B to the 9, the 9 is divisible by 3. You get 3. And b to the 1 inside. That's all we gotta do on 20C, okay? You guys can try the other ones. Almost done, guys. 21, find the domain. These are called radical functions. Radical functions that are even like a and b. You'll get one similar to those. You need to make sure that inside the square root you don't get negatives. So what we gotta do is we gotta do x plus 3. It must be a positive or it could be a 0. So greater than or equal to 0. Subtract 3 from both sides and you get x is greater than or equal to 3. Your domain is x has to be greater than or equal to -3. I'm okay with that, but some people are more specific on the notation, like set notation. The set of all x is such that x is greater than or equal to 3. Let's look at the answer, how they have it. That's right here. So we're fine. Just write it as that domain is x greater than or equal to -3. That's fine for your domain. Now on 22, find x such that f of x is equal to 0 for each function below. So f of x is 0. You replace f of x with 0. You work through this problem. Subtract the 8 first. Divide by 2. In order to get rid of square roots, you square. And this problem, I know it's not going to work. You're not going to get like this one. It's going to work. But if we do it, we're going to get -4 squared gives you 16. And again, the square gets rid of the square root. Let's add 4. So you get x equals 20. And the answer in the back is going to say extraneous because if you plug it in, it doesn't work. But as long as you're able to do this work, you'll get full credit from my part, okay? The next set of problems. It says here you can use a calculator. All right. So, and as a matter of fact, since we're going to be doing it on Canvas, you guys can use a calculator in all of these. But for face-to-face classes, you're going to have to, first part no calculator, second part calculator. All right. So here, what you guys are going to do on number 1 is figure out the equation of the line. You're going to have to figure out points. So since the year 2000, so the first point is going to be 1,408. The second point is going to be 3,771. All right, so you have to first find the slope. 771 minus 408 divided by 3 minus 1. y2 minus y1 divided by x2 minus x1. So you guys can use calculators for this. Definitely I encourage you guys to do it. The other problems were fairly easy, as you guys can see that you didn't need calculators. But in here you do. $363 divided by 2. You find out that the slope is 181.5. The next thing to do is to use the y minus y1 equals m. We already know m, right? That's 181.5. X minus x1. x1 is 1. So you go through the process, you distribute this, and you're gonna be able to figure out your equation of the line. Let me see. I want to use the space above to do this, so you guys can follow me. Y minus 408 equals 181.5 times x, 181.5 times -1 gives you that. right, when you distribute. And then lastly, we move the 408. So 408 minus 181.5 226.5. Y equals 181.5x plus 226.5. So now if we use variables appropriate for this problem, it should read something like this. We're talking about gastric bypass surgery. So instead of the y, g. Instead of the x, t for time. So this is how to find linear equation for number 1A. Now to find how many teenagers had gastric bypass surgery in 2006, the 2006 from the year 2000 is 6. You're going to replace 6 in 4t and then figure that number out. And that's 1b, okay? That should be a little easier. I'll let you guys do 1b, but that's how you do it. You replace t for 6. All right, let's go ahead and look at number 3. What you have to do is you find the inverse. So something similar to what we did above. You guys are going to replace d of t with y, t with x, interchange them, and then solve for y. Once you do that, that gives you the inverse. Okay, so I'm going to do this in one step, guys, because I don't have too much space. And so I'm going to first subtract 8400 to the other side and then divide by 650. So subtract 8400 and then divide by 650. That leaves me with y by itself. So this is your inverse. You need to be able to write it appropriately. So we're going to write t of d equals, and then you write the function that we got. D minus 8400 over 650. That's the appropriate way to write it, okay? So now the tuition for 3B, find the tuition, find the year when the tuition was 9,700. You replace 9,700 for D, 9,700 for D, and evaluate. 9,700 minus 8,400, whatever that is, that's 1,300 divided by 650. Is it 2? Three B. 3B. Yep, 2002. Okay, the year 2002, the tuition was $9,700. All right, so that was 3A and then B. Okay, number 5. Number 5 and number 6 are similar, so that's why I'm doing only one of those. All right, number 5. What is the weekly revenue from selling the refurbished nanos. So we have to read the problem, make sure we understand the variables. What is the R of n? R of n is refurbished iPod nanos. Right? No, it's the weekly revenue in dollars from selling, and then N is the refurbished iPod nanos. So R of N is the revenue in dollars weekly, N is the nanos. So 50, where are you guys going to plug it in? You guys are going to plug in 50 here and figure that number out. Just do your calculations. 50 minus 60, negative 10, square it, and so on and so forth. For B, it's going to ask for the maximum weekly revenue. To find the maximum weekly revenue, well, this is a parabola, concave down parabola. The maximum revenue is going to be that point right there, which we call the vertex. The vertex is the H and the K. 60 opposite sign. The K is 5700. So what does this mean? For selling 60 nanos, you'll get a maximum revenue of $5,700. It's as simple as that, guys. 5 and 6 are similar. You should try one of these. All right, number 7 and 8 are similar. If we try one of these, it should be fine. S of t. Suppose the newest version of your favorite smartphone comes out today. Assume that a total of 30 people go to your local cell phone dealer to purchase this phone today. And then each day after that, the number of people who purchase smartphone doubles. So figure out an equation for this. That's A. So the initial value is 30. The multiplier, this is an exponential because it doubles every day. It doubles. It's an exponential function raised to the t. Initial value, base multiplier, raised to the power of t. This is your exponential function. How many phones will there be after 7 days? So this 7 is your t. You plug in 7 there, 2 to the power of 7, whatever that is, times 30 will give you how many people buy a smartphone in 7 days. Answering complete sentences, guys, okay? Number 9 and number 10. Let's do one of these, guys. Number 9. Estimate the world population in 2015. What do we do with that 15? We plug it in for t. But now, this is very important. The years don't start in 2000, they start in 1975. So that means from 1975 to 2015, 25, 30, 40 years have elapsed. So we're going to have to replace 40 in for t. So 1.019 in your calculator, raise that to the power of 40 times 4. That gives you the world population in 2015. So I'll let you guys do that one, okay? Let's do B. When will it reach 10 billion? So 10 billion, do we put it in for t or do we put it in for p of t? T is time, so we're not going to put it in for t, we're going to put it in for p of t. We're going to put 10 billion 4 times, I need more space. Let me go up here to write this down. So I'm going to replace p of t with 10. And then I need to be able to solve for t. All right, so first I'm going to get rid of this 4 by dividing by 4 to both sides. 10 divided by 4 gives you 2.5. In order to solve exponentials, you have to use logs, just like we're doing up there in the problems without calculator, right? So I'm going to have to change it to a logarithm. So log, what's going to be my base? The 1.019 of 2.5 equals t. So you can enter this in your calculator. Log of 2.5 divided by log of 1.019 if you change a base, if you do the change of base. And then once you enter it into your calculator, 9b, it should read 2024. So 1975 this value right here should be about 49. Okay, when you enter into your calculator, make sure you guys get 49. And from 1975, 49 years later, that gives you 2024, which is what we see in the answers. All right, we see it in the answer right here. All right, so that was 9B. The other ones are a little easier, so I'll let you guys do the rest of number 9. And then lastly, number 10, number 11 and 12 are similar. If we do one, you should be okay with the other one. V of M is the average body speed, and then M is the body mass. So if the body mass is 0.5, we replace that in for M. .5, we replace it in for M. Use your calculator. Use your calculator to do this one. The square root of 0.5, punch it in the calculator, times 8.7, just going to go to the answers in the back. It gives you approximately 6.2. So that means V of M, right? The average velocity for a butterfly is 6.2 meters per second if the butterfly weighs 0.5 grams. Is that the units? Body mass in grams, yeah. If the butterfly weighs 0.5 grams, the speed is 6.2 meters per second. All right, 11B, they give you the 5 meters per second. We need to find the body mass. So we're going to, in this case, we're going to replace the 5 in for V of M. Instead of this, I'm going to replace it with a 5. And then we have to do a little bit of equation manipulation to solve this. Divide by 8.7. Do that in your calculator. Not sure exactly what that is. And then the next thing is to get rid of the square root. You square both sides, and that's how you figure out the M. 5 divided by 8.7, whatever that is, you square it. If we look at the very end, it turns out that it's 0.3. Okay, so all of you guys should be able to get 0.3. The butterfly weighs 0.3 grams when the speed is 5 meters per second. All right, and so this is the review, guys. You can pause at any time to make sure you study the steps that I've done, and let me know if there's any other questions, guys.